The differential between the blue and the red is the benefit, the environmental benefit of adding these drinking water bottles, these single-use bottles, to the bottle bill. Bottlers could make these bottles out of 25% recycled content and recycle them at a rate of 62%, or have them recycled at a rate of 62%. And that's what we have here in green. And so you see that adding recycled content offers some modest reduction in the environmental impact of this product. Some bottlers have really emphasized making their bottles as lightweight as possible. And that's waste prevention. That's the reduce part of reduce, reuse, recycle. And so if you reduce your bottle thickness down to 9.8 grams, which is easily doable, and some of the bottlers are already doing this, you get the results in purple. And so that's actually the most impactful, one of the most impactful things that the bottlers could do. It's more impactful than using recycled content or increasing the recycling rate. Okay, so that confirms the waste management hierarchy. Use less stuff first, and then look at recycled content and recycling. There is another waste prevention alternative that isn't shown on this graph, and let's look at that next. Here I'm going to expand these results. This is now 6 different impact categories, and we're going to compare first the same single-use PET bottle. Okay, you could buy it at the store, right? I'm not going to name any names, but you know who I'm talking about. It could be Aquafina, it could be Dasani, it could be someone like that. We're looking at actually an industry average here. And what we have here are the environmental impacts of buying that bottled water and sending it all off to be disposed of in Oregon, which is dominated by landfill, versus sending that bottle off to be recycled all the time, okay? And the disposal scenario is expressed here as 100%. The recycling scenario is expressed relative to the disposal scenario. Please do not get freaked out about this cancer number here. We are not saying that recycling plastic bottles causes cancer. The difference between the disposal and the recycling number is so small that it is essentially a statistical wash. It is not a meaningful difference. In contrast, we do have a meaningful difference in energy consumption and global warming potential. You can see here that from an energy perspective and a greenhouse gas perspective, there are meaningful, although moderate, benefits to recycling these plastic bottles. So if you've got the plastic bottles, we want them recycled. How does that compare against the real waste prevention alternative, which is drinking water out of the tap? That's what we've added here in magenta. Now, I want to emphasize that what we're showing here in magenta is really a worst case scenario for tap water. This is tap water that the consumer drinks in a bottle. We did an average of an aluminum, a polyethylene terephthalate, and a steel reusable container. And that they drink out of this once a day, and at the end of every day, they put the bottle in their home, they put this reusable container in their home dishwasher. And I know that most people don't do that, but they do. They put it in their home dishwasher, and it just happens to be the very worst performing, highest water and energy consuming dishwasher that has ever failed the EPA Energy Star program in the last 30 years of records that EPA had on dishwashers. So this is the worst home washing scenario possible, and you still get these great results, okay? Now we could compare a best case and a best case scenario. We could say, what if the single-use bottle were really super lightweight and were made in the most eco-groovy way possible, and it was totally local, and it was recycled at 100% rate, and that's fine. So let's compare that best case scenario for a single-use bottle recycled against a best case scenario for drinking out of the tap, like drinking out of something like this, but washing it once a week in an Energy Star dishwasher. And that's what we get here. In blue, we have the very best that you could do with recycling your eco-groovy PET bottles. And in magenta, we have the very best you could do just drinking water out of the tap in a reusable bottle. So again, this confirms the waste management hierarchy. Reduce first, then recycle. Here's another study that we completed a few years ago looking at e-commerce packaging. This is packaging that Amazon or LL Bean could use to ship items. And here we're looking specifically at non-breakable items. The materials that we evaluated that these order fulfillment centers could use to ship non-breakable items through the mail were a corrugated box with all these different kinds of void fills. Polystyrene, cornstarch, molded paper, those air pillows, crinkled paper, all kinds of sorts of different options. And then we looked at 5 different shipping bags. Unpadded bags, padded bags, all paper, all plastic, paper plastic blends, and then for every time you see an asterisk here, we evaluated a lower level of recycled content and a higher level of recycled content. We did this study in part because we were working with a couple of mail order fulfillment centers who really wanted to do the right thing, but it wasn't clear what the right thing was. Because from a recycling perspective, the box is the best choice. It contains high levels of recycled content. It's easy for consumers to recycle. The bags typically don't contain much recycled content, and if they're plastic or paper plastic blends, are very difficult to recycle. So from a recycling perspective and a keep stuff out of the landfill perspective, the box looks like it's the better choice. But the bags weigh a lot less. From a waste prevention perspective, they're the better choice. But at the end of the day, we don't care about prevention and recycling. We care about what the actual environmental impacts are. We want to know, how does this actually impact the environment? So let's take a look. We looked at all the petroleum used over the entire life cycle, okay? Cradle to grave, or cradle to cradle in the case of materials that are recycled. And what I've done here is I've taken our 26 different packaging options and I've condensed them into 4 different groups. First, on the top, we have our low post-consumer content box with a variety of low post-consumer content void fills. Then our high post-consumer content box with high post-consumer content void fills. And then our low post-consumer content shipping bags and our high post-consumer content shipping bags. And the scale on the bottom here is million BTUs of petroleum per 10,000 packages. How could this be? How could it be that the virgin double-layered, bubble-padded polyethylene evil shipping bag made from petrodollars could use less petroleum over its life cycle than the eco-groovy paper box with recyclable void fills? That certainly runs contrary to popular wisdom. But what we discovered as we looked at it is that there is petroleum used in the paper making process. There's petroleum used in transportation. There's also petroleum used to make the plastic bags, okay? But when you look at how much is actually used, because the bags weigh so little, all of the bags, whether they're made of paper or plastic, regardless of recycled content, all require significantly less petroleum than any of the box and void fill options. What about natural gas? Because natural gas is also used to make plastic. And here we have a little bit of overlap between the box and the bag options, but not much. Coal, over the life cycle, again, boxes on the top, bags on the bottom. Here's now switching over to some different pollutants. Here's atmospheric particulate, which is a contributor to asthma. Atmospheric oxides of nitrogen, a precursor of smog. Atmospheric mercury, a potent neurotoxin. Biological oxygen demand, this is a water pollutant. Waterborne suspended solids, another water pollutant. You're seeing some trends here, right? I'm not going to show you all the 80 different pollutants we looked at, but generally they followed this same pattern. And the reason is because even though some of these materials used to make the bags have more impact per pound when you make them, you use so little and they ship so compactly as well. But primarily you use so little that their environmental burdens are lower. Now here's another very surprising result. Here I'm looking at, what do we have here? 1, 2, 3, 4, 5, 10 different void fills that could be used inside that box, okay? Let me go back a slide here. People think that the void fills are really important. But remember, this is the same, up here on the top, we have the same box with 8 different void fills. This is the same box with 8 different void fills. So the width of this bar up on the top, the width of this bar is the variability that the void fills introduce. That's all. The placement of these bars all the way over here on the right is a consequence of making the box, okay, not the void fills. But regardless, people think the void fills are really important. So we looked more closely at the void fills. This is pounds of carbon dioxide just up to the, it's not the full life cycle, it's just getting to the distribution center. And I've shown 10 different void fills here with the lower recycled content ones on the left and the higher recycled content ones on the right. Now, if you look closely, you'll see that if you're comparing the same material, for example, let's do the second one, polystyrene void fill with no recycled content. And you compare that against the, I think it's this 1, 2, 3, 4, 5, 6, the 7th one here, polystyrene void fill with 30% recycled content.